Hello and welcome back to our series. Now we will know about Armstrong. What is Armstrong? Suppose there is one number that is I think 371. This is the Armstrong number. What Armstrong number actually is? Here we will count. There are 1, 2, 3 digit in the number. Digit is equal to 3. And what Armstrong means 3 power 3 means plus 7 power 3, I will explain it, and 1 power 3 should be is equal to 371, means the power of individual digit power raised to the all digit means 3 digit of individual, and summing it should be same as that number. The power of this number plus power of this number plus power of this number should give same answer. Now first of all we have to find how many digits are there. Let's talk about this here without program. Let's divide by 10 here. 10. If we reject the remainder from here, then we will get 37 here, and again if we divide, this is first digit we have giving, if we are again divided by 3, it will be something, means it is 3 and go more. Let's initialize the number. Int number is equal to n. I will set a count for how many digits are there. Count, and I will make a result. Sorry, I will say sum should be 0, that this will have all. First of all I will find count from here. First of all I will get the number from user, enter number to check Armstrong number. Let's scan it. %d, ampersand n. Never forget to use ampersand while scanning NC, because it will not assign to memory if we are not using ampersand. Let's first of all we will count is equal to, we will make count is equal to 0. Sorry, so we will use while loop. While we will assign n value to next variable. Suppose I say d should be equal to n here, so that we will not affect the value of n, and we can increment or decrement d here. D does not equal to 0 here. Up to when d is not equal to 0, it will move here. We will first increment count here. We will increment count here. Sorry, I was get the charge problem. Now I will divide number by 10. I will get d is equal to d divided by 10. This is integer type and it will regrade the remainder. Let's it will get, let's print count here, and let's know it is working or not. Count, let's build and run it. I will insert 1 2 3. Yes, it is 3. Again I will test it again, so that I should confirm it. 1 2 3 4 5 6. It should give 6. Yes, I have got it. Let's remove it. Now what should be done? We have get the count. We have to multiply individual number. Now suppose I have 1 2 3. When I divided by 10, I would get remainder here. I would get quotient is equal to 12 and remainder is equal to 3, and we can operate in this here. Let's use that. Again we will assign d is equal to n here, because d have been divided and divided, it changes to 0 here, and we have to again count this number. Same, we have to take same number, and we should not affect this number, so we have to compare this number with our this sum, means result, while d should not be equal to 0. D doesn't equal to 0. Then what we will do here? We should find the remainder here. I will remainder remainder is equal to, here I will first find d percentage 10. Percentage means we have to find the remainder, and I will make d is equal to d divided by 10, so that this is, I have 1 2 3. When I divided by, when I get a percentage here, I will get 3 here, and I should get 2 in next line. If I would make remain d as same, so I would get again 3. I have to get 2, so I have divided here 2. When I divide by 10, so sorry, I percentage here, remainder will be 2 again, and so on. Now I have to find sum is equal to, we have sum is equal to 0 here, and I have to find here this remainder power, where it has been gone, sorry, remainder power count. Remainder power count, I have to get it. Remainder power count, it is divided by 10, it has been removed, and every time I will get it. Sorry, I have to pass here sum to sum plus, means what the sum will be and will added later. Now I will print the number first, percentage d sum, so that we are doing, I want to check if we are doing right or not. Let's build and run it. While it is giving me some error here, it's a unexpected. Yes, we will do while here, not build and run it. Again it show me something here, count, no count, count. Yes, well, it should not give me now. Let's 1 2 3. It got crashed. What's actually happened here? It found count here. It found count here. Then d is equal to again n. D doesn't equal to 0. I have done mistake here. It is percentage d. Sorry for this. 1 2 3. it should not get I have get 1 here. I should get 3 power 3 is equal to 9. 9 plus 2 power 3 is equal to 3 power 3 81. 81 plus 8 is equal to, so I should get 90 here. What's happened here? It is moving right here but not giving answer here. Sum is equal to, this should be power count. Let's try to first print this value. We will not print that value. I will print something here. Suppose here I will make a d. I will assign d is equal to 2 power 3. So 3 power 3. So I have to check here it may working or not. I will pass here d. I should get here 5 0 because we have no d here. We have get 0 here. Something is wrong here. D power 3 power 3 we have done here, but we are not getting here. Let's make again function here. I should pass powering here. Power I should pass reminder and count. Let's make this function here integer power. I will get integer reminder here and integer count here. Let's see what happened here. Here we should make a multiplication here. Power means number of time we have to multiply reminder for how many time this is. Let's make reminder is equal to 0. Sorry, I will make next number 3 is equal to, sorry, b is equal to 1 here, and I will pass here another variable I. There should be integer for I is equal to, for I is equal to 1 and I is less than count, less than or equal to count I plus plus. We can simply we have to make b is equal to reminder multiply by, sorry, b multiply reminder, b multiply remainder means it will multiply 2 times. It is multiplying b is equal to 1 into remainder, then next time it will multiply remainder into remainder, and that will return simply b here. Return b here. I will return simply b here. Let's see if it's run. I am getting again its slow processes here due to this function. I think I should define this here, the int power int comma int have to pass here. Build and run it. Number I will enter 1 2 3 here. Let's here we have not done anything. Print simply sum here. Let's say its sum should be 1 2 3 should be 90. I get it 36. It should not be 36. 2 power 2 is equal to 4, 3 power 3 is equal to, yes, 36. 3, I have got confusion here. This is 36 true. Let's see how what's happen here. 3 multiply 3, this is 27. I think it is 81, so I have confusion here. This is 27 plus 2 raised to power 3 is 8 and 1 raised to power 3 is 1. This is 28. 28 plus 8 is 36. Yes, it is the right answer. Now this is not what we have to do. If n double is equal to sum, then print the number is Armstrong, otherwise we will print else we will print the number is not Armstrong number. Let's run it and find some Armstrong number. Let's print 1, it is Armstrong number, because 1 raised to power 1 is 1, up to 9 it will be Armstrong number. Let's print 8 also, it will be Armstrong number. Let's go with some more number. There I think 14, no, there should be some other number too that would result same number. I think in 2-digit number there I would think so much. I would just print 371 here. Yes, this is Armstrong number. 3 raised to power 3 is 27. 2 raised to power 7 raised to power 3 is 343 plus 27 is 43 or 7 is 70 and plus 1 is equal to 71. This is 73. They are Armstrong number. You can check more. If I enter 12, it is not Armstrong number, because 1 2 this is 2 4 5, it will be answer. This is how we can know about Armstrong number. What is Armstrong number we have studied here. Thank you for watching this video. We will do more example in next video. Thank you.